Hello again. We are moving on with our discussion of truth tables, and we're going to talk about logical equivalence. This is lesson 5.10, so here we go. Let's talk about truth tables. They can be constructed using any combination of conjunctions, disjunctions, negations, all that good stuff, even the exclusive ones. Each truth table is going to have a row for each possible combination of the original propositions. So depending on how many original propositions there are, we're going to need a certain number of rows. So let's talk about not P or Q. I want to see when that is true and when that is false. So here's my truth table. I'm going to put P in this column. I'm going to put Q in this column, not P in this column, and then I'm going to do my final one, not P or Q in this one. Okay, so the first possibility is when both P and Q are true. So when P and Q are both true, what happens in the last column? Well, let's talk about what not P will be equal to. Not P will be equal to false. So if I use an OR on the blue column and the red column, ORs are going to be true if either one of those is true or both. So Q is true even though not P is false, so that statement is true. Okay. Second possibility is when P is true and Q is false. So that would make not P false. So I have a false or a false, and that is false. The third possibility is when P is false and Q is true. So if that's the case, then not P is true. So I now have true or true. That's true. The last possibility is when P is false and Q is false. That means that not P is true, and that means that a false or a true is true. So that's the truth table for not P or Q. All right. Tautologies, those are those things that are always going to be true. Okay. For example, P or not P. Kind of an easy example of a tautology. Okay. So we're going to put P there, we're going to put not P there, and we're going to put P or not P there. So the only original proposition I have is P, and that can be true or false. So the first row is going to be true, and the second row is going to be what's going to happen when P is false. So when P is true, not P is false, and a true or a false is true. Okay? When P is false, that means that not P is true, and a false or a true is true. So anything that gives you the last column in your truth table having all trues, that's what we call a tautology. That's something that is always true. Okay? A logical contradiction is the opposite of that, and that's when all of the truth values in the final column are false. So if I have P and not Q, and Q or not P. Okay? So we're going to need 4 columns again because we have 2 original propositions, P and Q, and either one of those can be true or false. So there's 4 possibilities. Okay, I'm going to figure out what not P is and not Q for each of those values. I'm going to figure out the first set of parentheses, which is P and not Q. I'm going to figure out the second set of parentheses, which is Q or not P. And then I'm going to use and between the red and the blue. Okay. So if P is true and Q is true, that means that not P is false and not Q is also false. So P and not Q, that is a true and a false. That is false. Ands are only true when both parts are true. Q or not P, that is a true or a false, and that is true. Okay? Ors are true when either one or both of the original compositions are true. So now in the red column we have a false, we have a true in the blue column, and if I use an and on those, I get a false. Okay? So going back to the beginning of the next row, if P is true and Q is false, that means that not P is false and not Q is true. Okay? If I use an and on P and not Q, that's a true or a false, or a true and a false. Sorry, that's a true and a true. So that's going to be true. And then if I go to the blue column, a Q or a not P, that's going to be a false or a false. That's going to be false. So if I use an and on the red T and the blue F, that gives me false. Third possibility is when P is false and Q is true. That means that not P is true and not Q is false. P and not Q will be false, and Q or not P will be true in that case. But again, a false and a true will give me false. And the last thing that can happen is a false and a false. That means that not P is true, and not Q is also true. P and not Q is false, Q or not P is true, and a false and a true gives me false. So when you get every single element or every single cell in the last column to be false, that means what you have is a logical contradiction. Okay? Logical equivalences. That means that two propositions give you the same truth table. The last column is going to be the same for each of those different propositions. So if I have two propositions here, one of them is not P and not Q, and the other one is Q or not P. Okay? So there's P and there's Q. There's not Q. And we're just going to figure out each of those relatively quickly. You can easily slow down if you want to figure out this truth table yourself, but we've done enough of them to where you should be able to figure out how to fill these in with trues and falses. But obviously, if you're not sure, then rewatch some of the older videos, or you can always ask me during class how to fill these out. So I've filled out the first one, and now I'm filling out the second one in exactly the same way. Looking at all the possibilities of P and Q. And what you're noticing is in that yellow column at the very end, those are the two things that I'm comparing. And I'm getting exactly the same truth values in both of those columns. That means that those two statements are logically equivalent. They can be substituted for each other. They are basically saying the same thing, depending on, well, not depending on anything, but you would replace P with a statement, you would replace Q with a statement, and if you said either of those things, you would be saying the same thing. All right, so now we get on to three propositions, and I'm going to do this one relatively quickly as well. So for example, if I had R or P and Q. Okay, here's my table. Got to do P, Q, R. I'm going to put P and Q there, and I'm going to put my final one there. So because I have three propositions, that means that there's 8 possibilities. So there's 2 possibilities for Q, P, there's 2 possibilities for Q, and there's 2 possibilities for R. So that means I have 8 rows in my truth table. And I'm just going through. You have to be a little bit organized when you go through this process and make sure that you're not missing any rows or possibilities, and you're not duplicating any rows or possibilities. So just going through this. All right, and then once you're done, you have the different truth values for R or P and Q. And that's pretty much what you do. If you have any questions, let me know, and I will see you tomorrow.